So let's begin with a quick review of lines before we jump into linear regression and correlation. So first off, we're working in two space. In the XY plane, the horizontal axis is usually referred to as the x-axis. We'll call the vertical axis, the y-axis. Sometimes you'll hear y referred to as the response variable. We'll talk more about that later. And so the idea is you can pick any point in two space and you can think of it as an x comma y. There's sort of a triangle involved, if you will, where the x coordinate, this x coordinate is this distance, and the y coordinate, the second coordinate, is this distance. And so just to be very clear that we're all on the same page, let me just graph a couple of points. So if I go out 1, 2, 3, I can put a point right there. This would be the point 2, comma 3. It's always x, comma y. Okay, so let's think about lines now. So lines are just functions that are flat, are straight. And so we think of a line as the shortest distance between 2 points. And so maybe we have this point, we'll call this point x1, y1, and we'll call this point x2, comma y2. And so, of course, you can visualize in your mind already the line between them would look like that. And our goal is to actually find the formula for this line. I'm going to erase the tail there. There we go. I want to find an equation for this line that I can write down. And so let's first focus on the concept of slope. So slope measures how steep the line is. And the typical formula for slope is rise over run. We can write that down. Let me zoom back out here. So we'll say slope equals rise over run, and people usually use the letter m for slope, so I think I'll slide that over and we'll say slope m is rise over run. And so go back to our line here between these 2 points. You can look at the run, which would be this distance, and then this distance would be the run, if you will, and then this distance would be the rise. And so slope is just the rise over run. And so in that situation, in this situation, we can actually write down the slope of the line if we know one more thing. We just need the y-intercept. And so the y-intercept is just the point on the y-axis where the line crosses it. And so it's going to have the form 0, comma b, right? If you're on the y-axis, then x is 0. And so once you have the slope of the line and you have the y-intercept, then we come up with an equation. Our line looks like y equals m times x plus b. And so this is the slope-intercept form of a line. We often want to actually write the slope down, right? I just told you it's rise over run, but how do you actually compute that? Well, a nice formula for the slope m is this rise. What is that? That's a difference in the y values. So you take this y value and you subtract that y value. You get y2 minus y1, and then it's over run. That's the difference in the x value. So you take x2 minus x1, and you can actually compute the slope in this point. So that's how you do it. I'll do an example in just a moment with you, but I want to point out one other situation to you. A lot of times you're actually given a point on the line, say it's x naught, y naught, and we're given slope m. And the point is, the point you're given might not actually be the y-intercept. It might be just an arbitrary point. And you can still write down the equation of the line. It looks like this: y minus y naught equals m times x minus x naught. So those are the equations that we need. I want to do some examples with you now, and then we'll jump into what we want to talk about for stats.